Now, give equations for the reactions of ethanamide when hydrolyzed under acidic and under basic conditions. So we are going to hydrolyze the amide. I told you yesterday, amides are a bit like esters, except there is a link between the C double bond O carbon and a nitrogen atom. So just like you can hydrolyze an ester, you can also hydrolyze and break down the amide linkage. And we can, just like with esters, do it under acid conditions as well as do it under base conditions. Now look at under acid conditions. There's ethanamide, 2-carbon amide. Under acid conditions, so it's going to react with H3O plus, and what do we end up getting? CH3 C double bond O OH, because you will create the alkanoic acid, and the H plus will combine with NH2 here, which would be like ammonia initially, but then what happens? This is under acid conditions. The ammonia is a weak base. It won't just stay as ammonia. It'll grab the H plus from the acid and become the ammonium ion. So that's important that you show this as producing the ammonium ion. That's the ethanamide with H3O plus. You break down that bond, produce it's under acid conditions. So see, you get the free alkanoic acid, and you can think of it like producing ammonia, but this is under acid conditions. So the ammonia will change into the ammonium ion. Right. Then let's look at what happens under base conditions, which is also what they wanted next. So we have our the ethanamide under base conditions. You break that bond, and this is under base conditions. So our acid won't stay as the free acid, but it will be the corresponding alkanoate ion, the conjugate base of that alkanoic acid. CH3 C double bond O, O minus, right? The ethanoate ion. Because after breaking the amide link, you will then have the free acid. You can think about it this way, which will then react with the base to produce the ethanoate ion rather than free ethanoic acid. Of course, this is under base conditions, so the NH3 will stay as NH3. The base doesn't react with a base. Okay, acid-base reaction follows on after the breaking of the amide bond, which is an organic reaction. Don't think of that as an acid-base reaction. Okay. Then under basic conditions, again, just think, it breaks that amide bond. That's an organic reaction. But under base conditions, the result initially, you can think of it as being the acid. Okay, but this is under base conditions. Now our base will react with the acid to give you its conjugate base, the ethanoate ion. And under base conditions, the amine formed will stay as the amine, because a base doesn't react with a base. In this case, the amine is ammonia, so it stays as ammonia. And amide, if we represent it like this, C double bond O, nitrogen, and it can be connected to two hydrogens, a hydrogen and a carbon, anything, okay? There can be any sort of thing attached here. That's an amide. What happens in either situation, whether it's an acid or base, we can break that amide link. And this is what you'll initially get. Think of it this way. This is an easy way to think about what's going on. Don't write it as two steps like that, but I'm just telling you how to think about it, right there. And you will put on one hydrogen there. Now, then what happens is after that is different whether it's under acid or base conditions. Now, if it's under acid conditions, what happens? The acid stays the same. This one, RC double bond O, OH. But the base part, right, you know that the NH there, it will change into being N and H Let's say that was there, and two things connected here, and it will accept, there's a lone electron pair on that nitrogen, so it will accept another H plus, so I can connect it like this, and it's like the ammonium ion because NH3 is a base and this is under acid conditions. But if you did it under alkaline conditions, what happens? That's if you warmed it up, say with the sodium hydroxide solution to break up the amide, our base will stay as it is because that's not going to react with the base. Okay, so that will be like that. But our alkanoic acid will react with the base to give away an H plus, and you will end up with the alkanoate ion. Okay, Kiara, is that making sense?
Okay, yeah.
Okay?
Yeah, it does.
Okay, so think of it like this, that the amide linkage is broken, that's that step in the green. Then depending on whether it is acid conditions or alkaline conditions, the result is different.